All right, so this is a key to section 14.1 part A, and this is where we have rational expressions, and you want to evaluate these rational expressions at these particular variables. So for x, the value would be 3, y, the value is -4, and then z, the value is -2. All right, so basically, you're just going to, where we see the variable, you're just going to substitute these values for the variable, and then compute the numerator and then the denominator. Evaluate the expressions. So number one, you have x minus 7 divided by x plus 4. And so in this case, x is 3, so you're going to get 3 minus 7 divided by 3 plus 4. And then 3 minus 7 is a -4, and then 3 plus 4 is 7. So you get a -4 sevenths. And number 2, this time you're dealing with the variable y. Now y in this case is -4. Now you need to make sure that you understand that if you're raising a negative number to an even power, and even if it's any power, an odd, you need to make sure that you put that in parentheses, because if you don't, like if you just said this, which some of you will probably have done, this is a -16. This is not +16. So remember, if there's no parentheses, you're squaring the 4, and then 4 squared 16, you're taking the opposite of that. So the opposite of 16 is -16. So you need to put that in parentheses, because that's what you're squaring. You're not squaring 4, you're squaring a -4. And then since y is just being raised to the first power, I'm not going to use parentheses. So I'm just going to say -4, subtract 2. So I'm going to get 16, a +16, divided by -6, which reduced is a -8/3. Number 3. Okay, so you have z, which is a -2. So you have -2 divided by, now again, since z is being raised to a power, I'm just going to go ahead and put that in parentheses since it is negative. So I have -2 cubed plus 1. So I get a -2 in the numerator. The denominator, and -2 raised to the third power, is a -8. -8 plus 1 is a -7. Now, do not leave your answer as -2 divided by -7. You need to remember that a negative divided by a negative is a positive. So it's a +2/7. That's the answer you need to write. Okay, number 4, you're dealing with the variable x, which is 3, and so since 3 is positive and it's still being raised to a power other than 1, the x term here and the x term here, I'm going to put that in parentheses. So I'm going to get 3 squared minus 2 times 3 plus 4 divided by 3 squared plus 3 minus 3. All right, using the order of operations, let's deal with the numerator first. So 3 squared is 9. That's a numerator. And then minus 2 times 3 is a -6, and then plus 4. The denominator, 3 squared is 9. So you get 9 plus 3 minus 3. So in the numerator, you get 9 minus 6, which is 3. 3 plus 4 is 7. The denominator, 9 minus 3 is 12. 12 minus 3 is 9. So you get 7/9. Number 5. Again, your variable here is just z. Well, actually, yeah, just z, and then z is a -2. So there are situations where your rational expressions could have different variables, but in these, it was the same variable for each one. So z is a -2. Remember, right here, z is a -2. So where we see the variable z, I'm going to substitute -2. So I get -2 plus 3 divided by, and now again, since z is being raised to a power other than 1, I'm going to put that in parentheses. So -2 squared plus 2 times -2 plus 1. Now again, since z was negative, whenever it's being raised to power, always put that in parentheses, because remember, just keep in mind that especially if it's an even power, a -2 squared versus -2 squared in parentheses, those are different values. So again, this is -4, This is a positive 4. So you really need to be careful when you substitute negative numbers, that you're doing it correctly. So the numerator is just negative 2 plus 3, which is 1. The denominator, I get this. I get 4 right here. Negative 2 times itself is 4. 2 times negative 2 is a negative 4, and then plus 1. And then 4 minus 4 plus 1 is just 1, and then 1 divided by 1 is 1. All right, so that's part 1. That's the first page. The second page, with regards to these rational expressions, is that you also need to know how to determine where a rational expression is undefined. All right, so these are all rational expressions, a polynomial divided by a polynomial. These are all rational expressions. And you want to find out where each of these is undefined. Well, remember from previous courses that you can never divide by 0. So if the denominator is 0, remember that is undefined. It is okay for the numerator to be 0 and the denominator to be something other than 0. In this case, 0 divided by 8 is 0. So a fraction is undefined when the denominator is 0. So basically all you have to do in each of these cases is look at your denominators. That's all you have to do. Just look at your denominators and determine where those denominators are 0. That's all you have to do to determine where each of these rational expressions is undefined. So for number 6, I have 4x, that's my denominator. I want to find out where that's equal to 0, so just equal to 0. And then you solve for the variable x. So notice that 4x is a linear equation, so to get x by itself, I'm going to have to divide both sides by 4. 4 divided by 4 is 1, and so I get x to be 0 divided by 4, which is a 0. All right, so find any numbers for which the rational expression is undefined. Well, when x is 0, this rational expression is undefined. Number 7, now again, it doesn't matter what the numerator is. The numerator can be 0. It's just the denominator cannot be 0, so you're just focusing on the denominator. Over here, you have x minus 7 equals 0, so that's your denominator, so equal to 0. Again, that's linear, so I'm going to add 7 to both sides, so x equals 7 when I solve this linear equation. So what I found was that when x is 7, that makes my denominator 0. So the restriction, if you want to think about this in terms of restriction, the restriction would be that x cannot equal 7. That's what you would imply here. You're implying that when I evaluate this expression, I can use any number for x except 7, because 7 makes my denominator 0. Okay, over here, I have 7x minus 3. That's equal to 0. So again, that's a linear equation. So I'm going to solve for x. I'm going to add 3 to both sides. So I get 7x equal 3. And then I'm going to divide both sides by 7. So I found another value for x for which this rational expression is undefined. So when x is 3/7, that makes my denominator 0. So that means that in terms of restrictions, I can use any number for x except 3/7. So if I substitute any number for x here, plug in any number for x except 3/7 and any number for y doesn't matter. I can use any number for y. There's no restriction on the y here. But 3/7 will make it 0. So, but any other numbers, any other real number, I can find out what this expression is equal to. All right, now over here, for number 9, so this was number 8, and this was number 7, and this was number 6. Number 9, this time if you look at your denominator, I have this, and I said equals 0, but notice this time this is a quadratic equation. So I'm going to factor this quadratic equation. I'm going to go ahead and factor out an x. So I'm going to factor out an x. I get x times 3x minus 2 equals 0. And so notice I have two factors whose product is 0. So the 0 factor property says I set each one equal to 0. So I get x equals 0. And then over here I get 3x minus 2 equals 0. And so notice that I went from a quadratic equation to 2 linear. Well, this one's already solved for x, so I'm done with that one. for this linear equation, I'm going to add 2 to both sides, and then I'm going to divide by 3. Divide both sides by 3. So I found another value for x. So these are 2 values for x that makes this rational expression undefined because it makes my denominator 0. And you can check, let's say 0 right here. 3 times 0 is 0. 0 squared is 0. 3 times 0 is 0. 2 times 0 is 0, and 0 minus 0 is 0. And over here, where we had 3 sevenths, 7 times 3 sevenths, that's 3. And then minus 3, you get 0. So that makes your denominator 0. All right, so that's the idea there. So you're just finding out the values for x, or the values for the variable, because your variables don't always have to be x, by the way, in the denominator. But in this case, since all the variables are x's, you're finding the variables for the values for x that makes the denominator 0, because then that makes the rational expression undefined. So here you would say x equals 0, comma, x equal 2/3. And then in regards to restrictions, if you want to look at it that way, which is fine, with regards to restrictions, you would say x cannot equal 0, x cannot equal 2/3. Okay, over here, I'm going to set this denominator equals 0, so you get x squared plus 6x plus 8 equals 0. And again, this is a quadratic equation, and so I'm going to go ahead and factor this. The GCF here is 1, so I'm going to go directly to 2 binomials. And when I factor that, I'm going to get x plus 4 times x plus 2 equals 0. And again, just like I did this one, I'm going to use a zero factor property. So these are my 2 factors. I'm going to set each of those equal to 0. And so notice I went from a quadratic equation to 2 linear. And so when I solve each of those linear equations, I get -4 and -2. And if I just check, let's say -4, if I go back to the denominator, just verify that that is 0. -4 squared is 16. 6 times -4 is a -24. 16 and a -24 is -8. -8 plus 8, 0. And so x equal -4, x equal -2. Now, one other thing I just want to remind you is this. So that was the 10 problems, but what if you had something like this? Let's say we had number 11. And number 11, we had x plus 5 divided by, let's say, 3. All right, so I want to find out where this, and again, this is still a rational expression. A monomial can be, monomial is considered a polynomial. So you have a polynomial divided by polynomial, and notice it's okay for this monomial to be a constant. You don't always have to have a variable. So, but it's still considered a rational expression. So if you want to find out where this rational expression is undefined, you ask yourself, where is the denominator equal to 0? That's your question. Where is that equal to 0? Well, notice that you have 3 here. There's not 3x, it's just 3. So the question is 3 ever equal to 0? And the answer is no. 3 does not equal 0. So my denominator is never equal to 0. So that means that with regards to the question, find any numbers for x for which each rational expression is undefined, this rational expression is never undefined. So this rational expression is always defined for any value of x. All right, so in the blank, if I would have the word answer just like I did in the others, you would say none. Okay, so there are no values for x that makes this rational expression undefined. All right, so there are no restrictions. Okay, so just be aware, just in case there's a constant in the denominator, that that this is always going to be 3. It's never going to be 0. So this rational expression would always be defined. No matter what number you use for x, or any real number for x, I'm going to get a value for this rational expression. Okay, so that's going to take care of the key to this worksheet.